In this video, we're going to be learning about several theorems that talk about the zeros of polynomial functions. Let's talk a little bit about the vocabulary there before we get into the actual video here. First off, we're using the word theorems here. In mathematics, a theorem is a proven fact. It is guaranteed to be true. It's been proven mathematically. The only thing that you want to be careful with is that each theorem only works in certain scenarios, and they will tell you exactly when it works in the theorem itself. But as long as you are in the scenario, it is 100% true. Also, we have this word zeros here. So let's suppose you had a simple polynomial function like x squared minus 1. You've seen before when you wanted to graph this, you set it equal to 0. And what happened then was you found the x-intercepts. However, some people also call these the roots of the polynomial, and others call them the zeros of the polynomial. And so we will use these terms pretty much interchangeably here, but the terminology for this video are going to be zeros. Okay, so for our first theorem here, it is called the Remainder Theorem. It says if you have a polynomial and you divide it by the polynomial x minus a, then the remainder will equal f of a. So let's take a specific polynomial function here as an example. Let's do the x squared minus 1. And we're going to take that polynomial function and we're going to divide by x minus a. I'm going to pick a to be 2 here. So we're going to go ahead and do our long division here. X minus 2 goes into x squared plus minus 1. X goes into x squared x times x is x squared. X times minus 2 is minus 2x. Go ahead and do our subtraction here. X minus x cancel. We're going to get 2x minus 1. X goes into 2x 2 times. 2 times that is 2x minus 4. Do our subtractions here, and minus 1 plus 4 is 3. So that tells us that the remainder is 3. However, notice that if I had plugged my a number into the original function, I would have gotten 3 as well, the same answer. And what the remainder theorem tells us is this is not a coincidence. These two numbers will always give you the same answer. And so in a given problem, you can just go ahead and compare back and forth and see which one's easier to find, and then you find it that way, and then you get both answers at the same time. The next theorem is a very closely related one. It's called the Factor Theorem. It says that x minus a is one of the factors if and only if you plug in that number and you get 0. So for example, again, f of x is x squared minus 1. If you check very quickly and you plug in 1, you get 0. And anytime when you plug in a number and you get 0, which means it's an x-intercept, which means that it is a 0, which means it's a root, that guarantees that you'll be able to factor your polynomial with x minus that number right there. So again, the factor theorem just tells you that anytime you have a root or a 0, you're going to be able to factor the polynomial with x minus a involved there. And the reason why it's related to the remainder theorem is that if your f of a is 0, then your remainder is 0, and if your remainder is 0, that means you divide it evenly. So it's a factor. Next one is called Descartes' rule of signs. I'm not going to spend very much time on this. This is one of the theorems that I think is not super important, but regardless, that's my personal opinion. So let's take a look at, I don't know, let's do like an x cubed one here. Let's do x cubed minus 3x squared minus 5x plus 2. So suppose we're trying to find the zeros of this polynomial. What the Descartes rule of signs will say is, ask yourself how many times did the coefficients change back and forth between positive and negative. Well, we started out from positive 1 to negative 3, so that's a change. -3, -5, no change. And -5 to +2, that's a change. So we have two changes here. And what that means is that the number of positive real zeros is either the number of changes 2, or it has to be smaller than that by an even number. Well, the only thing that's smaller than that by an even number is going to be 0. So what Descartes' rule of signs tells us is that there's either 2 positive roots or there's no positive roots. And that's it. It doesn't tell us which one of those is actually true. It doesn't tell us what the actual roots are. All it does is tell us the possible number of positive real roots. Now, here's a small example where this might be useful. If you happen to have already found one positive root for the problem, well, then you would know there had to be a second one to look for. But again, it's not great theorem to use, but regardless, it's something we're studying here. Notice that if you want to find the negative real roots, you can also do a version of Descartes' rule of sign where you just take your function and replace the x with -x, and then you look for sign changes as a result of that, and that will tell you about the negative real roots. With all that said, the next theorem here, this is the big one. This is the most important of all these theorems on this video. I call it the rational root test here. What it says is if you have any polynomial, and I labeled out the coefficients here for some high degree, then the only possible rational numbers that are zeros are fractions of the form c over d, where c goes into the constant term and d goes into the leading term. So take a look at this polynomial right here. What you would do is you would look at the end, you'd see -6 here, and you ask yourself what possibly goes into -6 evenly. Well, you could have 1, 2, 3, or 6. Those are the only numbers that go into 6 evenly. Of course, you could have positive or negative of each of these. Then you look at the leading coefficient, which in this case is 1, and you ask yourself what can go into 1 evenly. Well, that's only 1. And then what you do is these things up here are going to be the numerators. The numbers down here are going to be denominators, and you try to look at any possible combination. And so then at the end of the day, you're going to get possible zeros of 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and 6 over 1 is 6. So basically what you've done is you've taken it from infinitely many possible answers to 8 possible answers, right? Plus or minus 1, 2, 3, 6, and 8. There's 8 possibilities. And then you can just try them and see if any of them work. It's much easier to try 8 things than it is to try infinitely many things. So that's the big deal about this theorem, is it allows us to take this infinitely many possible answers out and restrict it down to a finite number, and hopefully a small finite number of possibilities. I mean, if I gave you 100 possibilities, sure, you could try them all, but it'd be a gigantic pain. So hopefully the ones we get are going to be low, maybe less than 10 possibilities. Okay, there's 2 more theorems in this video. The next one is on bounds of zeros. Really quickly here, if you say have f of x is x squared minus 1, we know what the zeros are. We know the zeros are -1 and +1. And so if I had capital M to be 2, this is a number that is bigger than every possible zero that we have. This would be called an upper bound. This would be called an upper bound. And if I were to pick, I don't know, little m to be -5, this is something that's smaller than every possible zero. This would be a lower bound. And so this theorem just gives you a way to check whether a number is an upper bound or a lower bound. And once you're able to find an upper bound and lower bound, you now know that all the possible answers had to be in between there. So let's say that we didn't know what the zeros were. Just by this, we know they had to be somewhere between -5 and +2, and that limits the area of where we're going to look for them. So it can be kind of useful to get information, but it's still not actually telling you what the real value of the zero is. Now the last theorem here is called the intermediate value theorem. This is one that's very useful for things like your calculator or computer program to solve problems. It's not super useful for humans because it's really long and tedious. What it tells you is that if you ever have a polynomial and you found one value where it gets positive answer and one value where it gets a negative answer, then you are guaranteed to have a real zero somewhere between them. Now to see what this means, I give an example here. We're going to try to find the zeros of the function x cubed plus x minus 1. So if I were to plug in 0 here, I would get the answer -1. And if I were to plug in 1 here, I'd get the answer +1. So if you look at your number line here, we know that at 0 it's negative, and at 1 it is positive. And so by the intermediate value theorem, somewhere in between there, it's going to have a 0. Now, just like on our previous theorems, it does not tell us exactly what the value is. It does not tell us exactly what the 0 is that we are looking for. All we know is that it's somewhere between 0 and 1. Now, at this point, let me show you what a computer could do. A computer could say, okay, it's somewhere between 0 and 1. Well, let's break that up into two parts. Let's go to the 0.5 here. And then let's go ahead and plug in 0.5 into my calculator or computer program. I'm going to get a -0.375. So what that means at this point here, it's negative. So now I know that there's an answer somewhere between 0.5 and 1, because that's where it went from negative to positive. So I've narrowed things down. And I say, okay, well, let's go a little bit more. Let's go halfway between there. This is going to be at 0.75, so let's go ahead and do 0.75 cubed plus 0.75 minus 1. And this is, again, something you would not really want to do by hand, but calculators are great. And I don't even care exactly what number it is, all I care that it's positive. And so now I know the answer is somewhere between 0.5 and 0.75. So I'm narrowing down where the possible answer could be here. And the next halfway point is 0.625. And if I plug that in, I'm going to get a negative answer. So now I know I'm between 0.625 and 0.75. And the next one here is going to be at 0.6875. I swear we're actually going somewhere with this. And I'm going to get a positive answer there. And so what I've done is after doing like 4 or 5 steps of this, I know the answer is between 0.625 and 0.6875. Now the intermediate value theorem does not tell me the exact correct answer, but look at this. Every number that's between 0.625 and 0.6875, that means when I solve the answer, it's going to start out 0.6 and then something. Every number is going to start 0.6 something. And if you kept repeating this more and more, you maybe get the second decimal place down for sure. And then maybe the third decimal place down for sure. And if you do this like a million steps, you can get down to, say, the first 10 decimal places down, or more probably. But regardless, your calculator only gives you 8 decimal places in the first place, so this is how your calculator can get the answer. Your calculator doesn't know the exact perfect answer, but it knows ways like this to approximate it. So the intermediate value theorem is a pretty useful theorem to try to solve problems by a computer program, but it's really long and tedious to try to do by hand. So it's a good thing to throw in there, but it's not something great for like me to have you do on a test. Okay, so this is an overview of all these theorems. In the next video, we're going to see how to use these to actually find the zeros.